have a vocab test today. I'm gonna cry. I've been studying since before 0 period. I'm scared.
Well, a lot of them I already knew just from like remembering, yeah, like last year and remembering World War II. Honestly.
Well, see, I remember it. Yes. Except science. I always remember science.
See, I'm the opposite. Like, if it's history, I can remember it, but like,
see, history, like,
I have
like, I got this. You know what I mean?
science.
It doesn't stick.
Carter was on that up and up train.
Like it does, baby.
I guess it's just because I like it a lot better than I do anything else.
Alright guys, we are only working on 10. Only working on 10. Number 10. Do we remember how to factor cubes? The formula?
It's like A plus B.
A plus B. Remember SOAP? Same sign, opposite sign, right? Next one's opposite.
And then it's B squared over here.
It's A squared first.
Squared, you know.
And then opposite sign would be a negative, right?
Yeah.
And then what?
AB.
2 times AB. And then always positive, then B squared, right? Alright, so your A is just X. So it's X plus,
4.
how'd you get 4?
Well, it's the square root of 64.
It's the cube root of 64. There you go. 4 times 4 times 4 is 64. Very good. Alright, so A squared, it would be X squared. And then minus 2 times A times B would be 2 times X. So let's write that up here. 2 times X times 4, which is 8X. And then always positive. B squared is 4 squared, which is 16. Do you see anything? Because it is equal to 0. I can keep going. You factor. Factors of the back number that add or subtract to be negative 8. What's the factors of 16 that add or subtract to be negative 8?
Negative 4 minus 4.
Negative 4 minus 4. Oh my goodness, how many minus 4s do I have? 2. Dos. So what are my 2 x values? Positive 4 right here and negative 4 right there. Very good. Y'all okay? Yes, no, maybe? Ooh, okay. It's coming. It's coming. It's coming. Remember that graph and stuff that y'all hated so much? What happens right here at positive 4? A parabola. What happens at negative 4?
A straight line.
A straight line. And when you put all 3 of them together, what kind of graph does the cube make? The little nene graph, right? The little crooked little thing like that? Y'all okay? Alright, here we go. We're going to do 11 tomorrow. We're going to do 12 on, what would that be, Thursday? I'm lost track of days now with Monday being all crazy. Okay, so and then test is on Friday, right? Okay, I will have your quizzes ready for you tomorrow. I didn't grade them yet because there were so many that were not finished and so many people that hadn't started them yet, but I will grade them tomorrow. My other classes were phenomenal, and I'm sure yours will be just as awesome because they're always right on par with everybody. So right now, let us grab our notes from chapter 6, section 3. Keep your ACT stuff. Don't forget to sign up for the ACT if you hadn't already. Okay, when starting to study for your test, remember that page 5 was an awesome extra problems at the bottom, especially for that division, because that division is what got a couple of us on our checkpoints and what got a couple of us on our quizzes, okay? Don't let it get you on your test. Okay, then, do not forget to study section 6-2. If you look at your calendar, it tells you every single section that's on your quiz and every single section that's on your test, okay? So make sure that you look at inverses. and make sure that you look at how to tell if it's an inverse or not. So guys, how do you tell if it's an inverse? You do the composition of both of them, right? And what must your answer come out to be in order for them to be inverses? They have to come out to be x. If they don't come out to be x like this one, it is not inverses, okay? So please make sure that you go back over that before your test. All right, then the back of that is, what is that, page 8? Is that right? Is this page 8? Okay, this is an awesome page for you to start studying for your test. If you need it to study for your quiz tonight, a couple of you haven't taken your quiz yet, then you can use that to study for your quiz, okay? Is everybody lost? Is everybody okay? Anybody lost? Excuse me. Is everybody okay? All right. So let's look at what we have next. I sent you an email over the break that we had about this homework. This is homework, and when is it due? Tomorrow, okay? It's page 9 and page 10. If you notice on the back, number 9 and number 10 got cut off when I copied it, okay? There was 1,001 copies that I gave you, and I honestly just didn't catch it. So what I did was I emailed you a nice, pretty copy for, and then unfortunately a lot of you were trying to look at it on your phones. When you looked at it on your phone, it wouldn't download correctly. So I sent you another email where I put it in Google Documents, so you could pull up your Google Document app and you could see everything then, okay? Okay. Now, if you can't get this pulled up, and if you can't get number 9 and 10 from someone, then what should you do? Come to the 0 period tomorrow, or after school, or during lunch, and I'll print you another one off. Or you can go to the library and print one off in the morning or something, okay? Is everybody okay?
So we're not turning this in.
We are turning it in tomorrow. If you have it ready and you want to turn it in, by all means, go ahead and turn it in. All right, so now we are starting on section 6.3, and this is page 11 at the bottom of your notes, page 11. All right, we got a lot to get through today, okay? But it's not that terrible. All right, here's one thing. Y'all ready? Okay. At the top, there's a definition. Not really a definition, but a keyword right up here. So let's read. Somebody want to read this up here for me? Get it? Got a good go. Who?
What do you want me to read?
Go ahead, Matthew.
If a function contains the square root of a variable, it is called a square root function. The function is a type of function.
Oh, the square root function is a type of what? Radical function. That's one definition you need to know. The square root function is a type of radical function. You might want to make a hint, hint. I'm just saying. Hint, hint. You might want to make sure you know that definition. You got me? And here's another one. If a function contains the square root of a variable, it is called a square root function. Oh my goodness. Just saying. I'm just saying. You might want to know that. Those two definitions, okay? Hint, hint. What is that? 4 times I said that now? Hint, hint. 5 times I said it now.
6.
Got it? Get it, got it good? Just saying. Ma'am?
Can you make it an even number?
Hint, hint. Just saying. Might want to know that for your
You
test.
said it 8 times.
That's 6 times. 5 plus 1 is 6.
Ooh, hint, hint. You say it twice.
That's once. Hint, hint is once. Okay, here we go. Parent functions. Remember us talking about that? And that's one of the things that I told you not to throw away out of your stuff was your parent functions. All the, what was it, 5 that we did or 6? I can't remember. 5 or 6. All right. The domain. Let's talk about the domain. This is set notation, and we don't do set notation. It's not wrong. We just haven't learned it. What is the domain of this? Okay, so where is this starting at? Where are your x's on the left starting at? 0. Because remember, I'm just worried about x's. And where does it go to the right? Positive infinity. There you go. All right, let's do the same thing on the range. Let's fix the range, okay? Because we don't do set notation, we do interval notation. Bottom to top, what's the bottommost y value? 0. And slowly, it doesn't flatline right here. It's going to slowly keep doing what? Going up to positive infinity. Y'all okay? All right. Where are the intercepts? What does that mean? That means it hits the x-axis at what number? 0. And f of x is the same as y, so it hits the y-axis at what number? 0. What does this mean? Not defined for x less than 0. What does that mean?
It's not negative.
It's what?
It's not negative.
Not that it's not negative, it can't be negative, right? Because what happens when you square root a negative?
You get a positive. No, you get an I.
You get the imaginary numbers, right? So it can't be anything to the left. All right, in behavior, here's what you need to know right here. Remember this from a couple of tests before Christmas? It's been a minute. So, as your x's are going to 0 right here, as your x's are going to 0, what are your y's doing as well? They're going to 0. As your x's are going to positive infinity, what are your y's also doing? Positive infinity. Does that make sense to everybody? Okay. Or you can just look at both of your domains and ranges and both of your domain and ranges. Got it good? All right, let's look at this problem down here. Number 1A at the bottom. Let's see, let's slide that up so y'all can see it. Identify the domain and range of each function. So, how in the world do you find the domain and range of each function?
Your calculator.
Oh, did I not turn my phone off? Hold on.
I'm gonna have to take that out. You get the input.
How many times have I taken yours up? So zip it. Alright, so what you do is you take this, what's inside, which is x minus 3, correct? Got it good? Alright, and where does it have to go? All of your x's have to go which direction, right or left, for it to be?
Right.
Yeah, they have to go right. So is that going to be less than or equal to, or is that going to be greater than or equal to? Greater than or equal to. That's why it's greater than or equal to, okay? Every single time. It'd be greater than or equal to. Now solve for x so that you can find your x's, right? Find your domain. You're going to add that 3 over. So it's all of your x's that are greater than or equal to 3, right? So how would I write my domain? Where do my domains start at? 3. And where do they go to? If it's greater than 3, going to positive infinity. See, that wasn't so bad, right? Okay. To find your range, let's find our range. Remember, this has been a minute since we've done this, right? If you have inside a number, that number you take the opposite sign, right? Oh my goodness, now it's positive 3. And you move left and right, correct? So this one would move right 3. Then anything outside moves the graph where?
Up and down.
Up and down. Do I have anything outside here of the radical? No. So where does that mean it's going? My range is going to start from?
0.
Your range is going to stay at 0. And it's still going to be to positive infinity. Let's look at this one. You ready? The only thing for your domain is what's inside. So what's inside the radical? X plus 6. And where do your domains have to go? To the left or to the right? Which is greater than or equal to 0. Move the 6. And you get negative 6.
Wait, what do you mean by left? Like left on the graph?
Right. They have to go right. Look at this graph. They have to go to the right. Because everything to the left, all of your x's to the left are negative. Your x's cannot be negative inside a square root. That's why it's greater, because all of your x's have to go this way. It's everything bigger. It's everything to the right. Your x's get bigger as you go to the right.
Yeah, but what if the graph is to the left?
We're getting there. And plus, what will it have in the front up here? Negative would flip it upside down, right? We hadn't gotten to the, we won't get to the ones that go left quite yet. All All right, here we go. So what's my domain? There you go. Doesn't that make sense? When it's inside, don't you take the opposite sign, which is -6, and move left and right? All right. What about my range? Now this one is different. There you go, Brinkley. Because that 2 is outside of the radical, right? You got a test Friday. It's the very first test of the semester. Yep, like what we did here. Yep. This 2, when it was outside, you kept the sign and it moved up and down, correct? So this one moves up 2. We're going to graph in just a minute, okay? So don't worry about that. So your range is from 2 to positive infinity. What's wrong? All right, if you haven't numbered it already, this is page 11, so make sure you number it, okay? All right, let's go to the back. All right, now what are we going to do? Ow. Hello? Ooh. Did y'all stay up too late last night? Yes? No. 9:30? Are you for real?
I was exhausted.
Whew. I wish I could go to bed that early. Okay, so what's it say at the top? Let's see. D, can you read us at the top up here?
The same techniques used to transform the graph of other functions used can be applied to the graph of square root.
So same thing that we've talked about. If it's inside, you take the opposite sign. So if it's inside, you take the opposite sign. And it moves left and right.
Wait, so did the other one move right to left?
If it's inside, it moves left to right. If it's outside, which is where the K is, you take the same sign, and where does it move? Up and down. There you go. Up for positive, down for negative. Is this bringing back some memories from like October-ish, somewhere around there? Okay, when we did the dreaded quadratics. What? You don't have memories from October? None. Were you in a coma in October? You were? Okay. All right, let's look at number 1. You ready? All right, it says graph. And then it says state the domain and range. Here we go. What does the -5 inside tell me to do? Go right. You take the opposite sign, which is +5, and +5s move right. All right, then to graph these. Remember when we did squares? We did the parabolas, and we did 1 squared was 1, so we went out 1, up 1. 2 squared was 4, so we went out 2, up 4. 3 squared was 9, so we went out 3, up 9. This time we're not going to square, we're going to square root. So what's the first perfect square? 1. Oh my Jesus. 1 is the first perfect square.
We count 1?
Yeah, you can count 1. Technically 0 is technically the first perfect square.
Let's count 1.
Because we already there, we already did it, that's why. All right, what's the square root of 1? Technically, it's plus and minus. Let's just remember that. But we're just going to do the positive one. So here we go. We're going to go out 1 and up 1. All right, what's the next perfect square?
2.
4. And the square root of 4 is 2. There you go. I know that's what you meant. So now you're going to go over 4, but I don't have enough room, right? So we'll just keep it like this for right now. What was that?
That's so ugly.
It's a tiny little graph. Okay, state the domain and range. So what's the domain?
Domain is
5, 2. Perfect. And what's the range? Now look, you got to follow it over from this dot. Follow it over. What's that y value? 0, 2, positive infinity. There you go. All right, let's do number 2. Number 2. What does the positive 3 inside tell me to do? Left 3. Do negative 3, right? When it's outside, you keep the same sign and you move up and down. So where's a positive 2 tell you to go?
Up 2.
So here's what you're going to do. You're going to move left 3 and then up 2. Then you put your dot. Now, Gracie, princess, here we go. Square root of 1 is 1, so you go out 1 and up 1. Yes, ma'am, I'm sorry. You may go back over that?
Yeah, like vertical.
Where?
Oh, just, okay, so the outside number just tells you, like, if you go up.
Uh-huh. And you keep the same sign. So since it's positive, we moved up 2. Got it? All right. Next perfect square is 4. What's the square root of 4? 2. So 4 is what you do first. From that original dot, from your vertex, you go over 4 and up 2. What's the next perfect square? 9. Square root of 9 is? From your original dot, from your vertex, go over 9 and up 3. I don't have any more room, but if you wanted to, the next perfect square is 16. So you'd go over 16, up 4.
So you start from the first.
Start from the very first one every time. Y'all okay? What about your domain and range? Y'all want to try that real quick and we'll go over it?
Yeah.
All right, y'all try it real quick.
See what you can do with it.
And then we're going to 3 and 4. If you know how to do domain and range, go ahead and see if you can move to 3 and 4.
It's just been a minute since you've done it. What are you doing with that? You're adding, subtracting, multiplying. You do the same thing for the square root.
Yeah, we did. It's just been a minute. All right, what's my domain?
Negative 3.
Negative 3 to infinity. And your range?
2.
There you go. All right, now it has been a minute since we have done number 4, and we only did 2 problems like that in your notes. So it's been a few minutes. So let's, or not number 4, number 3, excuse me. What is different?
Multiplication.
Let me do this real quick so that we can. Wow, where?
Okay, how did you graph?
Number 2?
Yeah, like after you put the 3 2.
Okay, so it is
oh dang, I already moved it. Okay, here we go. So this is 1, so from your original, you went over 1, and then what you got goes up 1, then you go back to the original dot, you go over 4, and up 2. Yep.
So you go back to your original dot every time.
Every single time. Yep. All right, that page is still on the right-hand side for anybody that needs it. Let's see, this was page 12, right? Make sure you label it number 12 at the bottom. All right, number 3. Some of us have already started. Go ahead and find your vertex for number 3. Your vertex is where you start, right? Because remember, this is a parabola turned sideways.
Yeah, because it can't go negative.
Uh-huh. All right. So what does the negative 5 inside the radical tell me to do? Right 5. And what does the negative 6 tells you to go down 6? Very good. So let's do that first. Does anybody need that page on the left anymore? Anybody? Okay. Let's go back to the regular screen. All right. So, from here, this little bad boy right here, he does something.
he squeezes the graph.
It doesn't reflect it. Reflects this when it's negative. All right, well, let's see. What does this 2 do? You ready?
It decreases the slope.
No. So, what is the square root of 1? 1
Times 2.
times 2. Very good. Because of this multiplying by 2 up here. So now I'm going to go right 1, up 2. Perfect. All right, let's do another one. I know we don't have enough room, but let's just do another one. What's the square root of 4? 2, and then you have to multiply by 2. So from the original dot, you would go right 4 and up 4, right? I know we don't have any more room. We're just going over the motions. So do you see how it got steeper? It made the slope get steeper. So it actually stretched it
That's,
vertically. What?
but isn't that, like, if you're doing a parabola, doesn't that make the graph smaller?
No, it actually makes the graph wider. It's the fractions that make it
I thought it
skinnier.
was the other way around, because I remember we were doing something in
But remember, stretching it horizontally is the same as shrinking it vertically, because it's getting wider and it's getting shorter. That's probably where you're getting confused,
maybe.
because they're the same thing. All right, let's go to 4. You ready? Oh, wait, well, we didn't do domain and range. Oops. What's my domain? Quick, quick, quick. 5 to positive infinity. What's my range?
Negative 6 to positive infinity.
Perfect. Perfect. All right, let's go to 4. Here we go. All right, what does the 1 inside tell me to do? Go right 1. Yes, ma'am, I can. All right, what does the 4 on the outside? Down 4. So let's do that real quick. But I see 2 things. What's the first thing you see?
The negative.
The negative does what? Flips it where? Over the x-axis, right? So instead of going right and up, I'm going to go right and down. Does that make sense to everybody? So the negative flips it. It doesn't flip it over the y-axis. That's what you're going to do when you get to pre-cal, okay? Right now, we're going to flip over the x-axis. We're going to flip up and down. All right, the 1/5 is going to make things a little tricky. You ready? What's the square root of 1? 1, and then you're going to multiply it by 1/5. Wait.
1.2.
You're trying to add, multiply.
1.8.
It's the same. It's 1/5.
It's the same as 1/5, but what is that as a decimal?
0.2.
0.2. Not 1.2. 0.2. That's what I was saying you were trying to add. So this time, you're going to have to be real careful. You ready? We're going to go right 1, and down 0.2 means I'm going to go down just a hair. Just a little bit. All right, what's the next one? Square root of 4, right?
Negative 0.4.
2 times 1/5. What's 2 times 1/5?
Negative.
0.4. Technically, if you want to do negatives, that is the same thing. Yeah. So this time we're going to go right. We're going to start at our original dot. We're going to go right 4 and down 0.4. Now, where is 0.4? Almost the middle, right? Now, because we're not like computers, we're going to put it just about in the middle. And I don't have any more room because the next one would be 9. I don't have any more room. So it's very, very, very skinny.
I was just kind of looking at it as, since 1 is the top number,
Yeah?
that you just add a 5th every square root.
Yeah. Since it's 2, you just multiply this by 2.
But how many times do you go over?
4 from the original dot. 1, 2, 3. Oh, dang. I didn't count. I'm sorry. I thought I went 4. Right there. Don't look at that first dot. I'm sorry, Sydney. I just didn't count correctly. Bless you. Okay. So, what we're going to do the rest of the class period is we're going to finish up 1 through 7, but before that, we are going to do number 8 together, okay? You ready for number 8? Real life problem? All right, let's see. Who wants to read it for me? Who's got it? Who said that? Matthew, did you say that? Did you say that? Gracie, can you read number 8 for us, please, dear?
The speed that a tsunami or tidal wave can travel is modeled by the equation v equals d6 times the square root of g, where v is the speed in kilometers per hour and g is the average depth of the water in meters. The tsunami is found to be traveling at 145 kilometers per hour. What is the average depth of the water? Find the next 100.
Okay, so what I wrote down first is my formula. I'm writing down my givens, right? They give me the formula. They give me what V is. V is the speed in kilometers. And they give me what D is, which stands for the average depth of the water, right? What else do they give me? They give me some numbers. How fast it's traveling, right? So which one is that? Is that V or is that D? That's V. So the speed is 145 kilometers per hour. All right, so here we go. So what can we do? We can plug it in. Instead of V, I can put 145. And I don't know D, right? So that means that I am solving for D. So what can I do first to solve for D? Divide. And remember that we want to keep that 145 over 356. You don't want to do decimals unless the decimal does what? Terminates, right? A couple of you are taking the AP exam. I know it's English, but when you take the AP exam for a math or a science class, if you round too early, it's going to mess up your final answer. And if you have too many rounding calculations, when you get to the very bottom, your answer is going to be quite different from what you should have gotten, okay? So, here we go. What does 145 over 356 equal? Square root of D. There you go. And that is not my answer yet. How do I get D by itself? You square. It's already square rooted, so you square both sides. D's cancel out. You got your handy dandy calculator? Let me show you how to plug this in. Let me zoom this out. First thing that we do is we put a parentheses, and then 145 divided by 356. Close your parentheses, and then that is squared. What'd you get as your answer? Alright, now let me show you what happens. So let's write our answer down first, and then let me show you what happens if we would have rounded. Your decimal is going to be a little off. So, let's see, 166. I know it says round to the 100th, but remember AP exams want you to round to 3 decimals, right? And what is the depth measured in units? Kilometers, kilometers, there you go. No. Yeah. Now watch what happens if I were to divide it first. So I got 0.407. See how it's a little off? Like big time off? Yeah. So make sure that you put everything in your calculator. And, oh, I'm sorry. We weren't supposed to square root it. We were supposed to square that. That's why it was so off. It shouldn't have been that much off. There we go. See? So this is 589. This is 5649. This one's not a big deal because we only rounded once. But when you get problems where you round several times, it'll make a big difference by the time you get to the bottom. All right, everybody good? All right. On the back of this, you ready? Page 14. Dun, dun, dun. There's your graphs right there. So if it says to graph, let's see, what numbers does it say to graph for? 4 through 7. So this is the graph for number 4. This is the graph for number 5. This is number 6. And this is number 7. Are y'all okay? Okay. All right. All it says to do on 1, 2, and 3 is identify the domain and range, okay? So you got about 5 minutes left. Yes, ma'am. This is not for homework. This is what we're doing right now. What's your homework tonight? Page 9 and page 10. Now, these are good problems to help me do what? Study. So if you're like, I got how to graph, I know how to do those, or maybe you just need to work on where they have a number in front, maybe you need to work on those, right? So go through and find the ones that you're weak on, the ones you really didn't understand how to do, and let's work on that.